In our previous video, we introduced you to the fundamentals and purpose of inferential statistics. Now, let's put our knowledge into action by examining how it is used in practical situations and the challenges that arise when using it as a tool for analysis. Inferential statistics helps us make conclusions about larger populations using sample data. These tools are useful for testing, market research, and predicting customer behavior. However, they also come with challenges. Let's explore the practical applications and potential pitfalls of this important analytical approach today on Art+Science. Hey there, I'm Kevin Hartman, Associate Professor at the University of Notre Dame and founder of the Art+Science Analytics Institute, where our mission is to make you a better data analyst. Inferential statistics shine in a whole host of real-world contexts. However, they are primarily used in 4 ways that make big impact today. A/B testing is crucial for decision-making in marketing, UX design, and product development. Inferential statistics determines if changes in variables like button colors or ad copy significantly affect outcomes like click-through rates or conversions. For example, testing 2 landing page designs with 1,000 visitors each can reveal if higher sign-up rates are due to design or random variation. Inferential statistics help generalize insights from a sample to the broader population when you can't survey the entire market. For example, a restaurant could conduct a survey on 300 patrons about menu preferences and use inferential statistics to estimate which dishes will appeal to all customers. Businesses use inferential statistics to make accurate predictions about customer behavior, product demand, and market conditions based on historical data. For example, a retail chain could project holiday season demand across 500 locations using sales data from just 50 of them. Inferential methods are used by governments, nonprofits, and corporations to measure program effectiveness as well. These tools help determine if initiatives should be implemented to the entire constituency based on their potential costs and impacts. For example, a healthcare organization may evaluate a wellness initiative's success in reducing absenteeism by comparing tests and control groups before adopting it company-wide. While inferential statistics are powerful, they have limitations that analysts must simply understand. Let's explore their impact on your conclusions. Inferential statistics relies on a quality sample. If the sample that you've collected does not accurately represent the population, or more importantly, if you don't know how the sample differs from the entire population so that you can make weightings and calibrate it to fit that broader population, that can lead to misleading or incorrect findings. In this way, we must, as analysts, watch out for sampling bias, where certain groups are over or underrepresented in the data and we just don't understand those differences well enough. As an example, a survey that mainly includes urban residents may not reflect perspectives from rural populations or suburban residents. To ensure credible results, use a randomized and representative sampling approach. As we learned in our previous video, a p-value below 0.05 shows statistical significance, but not always practical importance. It simply indicates that the effect observed is unlikely to occur by chance without measuring its magnitude or its relevance. Don't overinterpret small p-values as proof of significant impact, as there may be minimal real-world effects. Always consider both statistical significance with your p-value and real-world relevance by interpreting the data. Imagine you're running an online store and testing if changing the color of the Buy Now button on your website from blue to green increases sales. You conduct an A/B test of 10,000 visitors, and the p-value turns out to be 0.03, showing a statistically significant result. However, once you peer into the data, you see that the actual results are very small, less than 0.5%, less than half a percentage point on your sales when you switch to the green button. Also importantly, the p-value gives you no insight into who the change impacted, whether it improved conversions with high-value customers or lower-value ones. So while the p-value suggests a real effect, implementing the change may not always be worth it considering the potential costs, minimal impact, or with whom the change occurred. Inferential statistics can reveal relationships, but not causation, without controlling for confounding factors. Overlooking these variables leads to flawed conclusions. For example, a study linking coffee consumption and productivity might miss the fact that coffee drinkers also tend to work longer hours. As a heavy coffee drinker myself, I can attest to that fact. To control for hidden influences, sound experimental design and multivariate analysis are needed to root out those confounding factors. Inferential statistics work best when applied to populations that are similar to your sample. Extending findings to dissimilar populations risks errors. Conclusions should only be applied to groups or contexts represented in your data. For example, customer satisfaction findings from one region in the country may not apply to regions with different cultural or market dynamics. Be sure to consider the specific characteristics of your sample population when applying your findings to other areas. Inferential statistics can uncover insights, but their true value is in how we apply them. By addressing challenges and being thoughtful, we can turn statistical findings into actionable strategies. Here are 3 essential practices that you can adopt. A well-designed study is crucial for reliable inferential analysis. Define objectives and target populations, then create a representative sample through random sampling to minimize bias. Embrace randomization to control variables and reveal true effects when experimenting or studying behavior, such as A/B tests or email campaigns. Inferential statistics reveals patterns, but understanding them requires context. Use domain expertise and exploratory methods to validate findings before making big decisions. Like we always should, start with descriptive analysis to understand your data and spot trends or anomalies. From there, look for deeper patterns and connections through correlation analyses. Then move into inferential statistics and analysis with a solid understanding of trends and patterns you've seen and some hypotheses developed. This process ensures clean, well-understood data for your inferential tests. Qualitative research like customer interviews and feedback adds valuable context to these statistical results as well. Inferential statistics are a starting point, but not the final word. They provide a framework for predictions and hypothesis testing, but additional analysis is necessary to solidify conclusions. For more complex issues, use predictive modeling or machine learning to uncover deeper insights. To validate findings, conduct controlled experiments, such as randomized control trials, which establish causality more effectively than inferential methods alone. For instance, if inferential analysis suggests that higher loyalty program rewards increase retention, this should be confirmed through some real-world A/B testing. Converting insights into action requires more than just crunching numbers. Success depends on thoughtful design, contextual understanding, and recognizing limitations. By carefully approaching inferential statistics in this way, you can create strategies based on solid evidence and real-world relevance. Inferential statistics gives us a broader understanding of data and allows for predictions. Understanding their application and their limitations is important for responsible analysis and effective strategies. Next week, we'll explore key techniques in inferential statistics like t-tests and ANOVA tests and how to use them in Excel and Google Sheets. Thanks so much for watching. If you haven't already, take a moment and subscribe to this channel, like this video, and share it with anyone who you think is interested in data analytics. Every single week, we are bringing new, exciting, and important videos on data analytics to this channel, and we would love to have you there for the journey. Be sure to check out links in the video's description for additional Art+Science resources, and sign up for our newsletter to get exclusive tips, course updates, and more directly in your inbox. Thanks again for watching, and we'll see you in the next video.